So I'm going to look at an optimization problem. A closed rectangular box with a square base is to be constructed so that the volume is 4,000 centimeters cubed. Determine the dimensions of the box that will minimize the material needed. This is a very standard question. You could have a rectangular base or a square base box, or you could have an open box. Any of these are different examples that you do slightly differently. This question asks us to minimize the material needed. So that's minimizing the surface area. So we're going to need an equation for the surface area of a box. Let's draw our box out first. In all these optimization problems, it always helps to start with the diagram. We know that this box is square-based, so our dimensions here we're going to both call x on the bottom, and then the height is going to be y. Now, if you know your math, if it's a closed rectangular box, the optimum value is going to be a cube. So we're going to show through optimization that y is going to be x, and it'll just be the cube root of 4,000 that will give us this minimum amount of material needed. Okay, so I said we need this surface area equation. We're going to have the base and the top both being equal to x squared, so 2x squared, and then 4x by y, plus 4xy, where the volume here is given as x squared y, which equals 4,000. Okay? Now we need to determine these dimensions. So I always like to say if we're optimizing surface area, we're going to need surface area as a function of one value. So we're going to need surface area here as a function, and let's make it as a function of x, because we can rearrange y to equal 4,000 divided by x squared. So surface area as a function of x equals 2x squared plus 4x times 4,000 over x squared. We can simplify that to be 2x squared, 1x crosses out, plus 16,000 over x. Okay? That's the equation that we need to take the derivative of. Once we do that, we set it equal to 0, and we can find the minimum amount of material needed. Setting it equal to 0 gets those critical points. It gets a max or min. We're going to have one answer here, and it will be our minimum. So we should have 4x plus, so this is going to be negative 16,000 all over x squared. Okay? Set that equal to 0. I'm going to bring this term over the other side. Negative 16,000 over x squared equals 4x. Therefore, sorry, this should be positive. 16,000 over x squared equals 4x. Therefore, divide by 4 and multiply by x squared. 4,000 equals x cubed. And the cube root of 4,000 gives us x. Cube root of 4,000 gives us x, meaning that it is in fact the cube root of 4,000 being our dimensions. So x, y, they will all be, and I believe it works out to be about 15.9. So the cube root of 4,000 is x. So x by y by x is going to be 15.9 by 15.9 by 15.9 centimeters. And that's the first optimization example.